Cool.
Awesome. Okay.
Yeah, let's just wait like 5 minutes so everyone can join.
Okay.
Can you see my screen?
I can see your screen.
Okay, cool. All right. There you go. All right. All right, everyone. So I'm just gonna wait like a couple minutes. So we're still like 5 minutes away. So let's just give it 5 minutes so everyone can join to a live stream or hear the channel, the Zoom call, and we can get started. Okay. Hey, Bob.
Hello, how are you?
We're almost ready. We're live already. We're just waiting a couple of minutes for people to join. This is the time that if we were in a live event, we start networking.
Oh, I know. That's one of the biggest challenges right now is that the SAS starter and another program I went through was good because it had like breakout rooms where you can meet people and it was targeted for that. But
Nice,
you don't get the just, hey, how are you conversation.
Yeah, that's sad. We might need to look into the breakout room then in the future.
Yeah. Those platforms cost money though.
Yeah.
And I don't know, there might be minimums on there that make it less affordable when you have a smaller group.
Yeah, we need to see that. I mean, I think Zoom has breakout room, but I need to see. I mean, how much is that?
I do have one I can share with you later.
Okay, sounds good. All right, so I think we can just get started. I mean, we shy 1 minute, so
yeah,
it's not gonna hurt. All right, everyone here in the call and people joining on in the YouTube video. Before we get started, I mean, this is a community-based event, and we love to share knowledge and love. So I want to just quick shout out to the Florida JS meetup, and please go and subscribe also to his channel. The leader there is Damian Montero. We actually in the same leadership community here in Palm Beach. So show some love, go join the meetup and subscribe for the YouTube channel as well. Okay. So this is a community. So let's help each other. And with that being said, so today we're going to start with the topic that we have on hand, which is we're going to be talking about Ssl, Let's Encrypt, Kubernetes, and Cert-manager. There's a lot to cover, so I'm going to just get started right away because we got a lot of concept to cover. So let's get started. The first thing on hand is like, who am I? I'm Miguel Ramirez, CEO of Cuemby. I'm basically passionate about everything related with cloud native, Kubernetes. I'm a certified administrator. I'm a part of the team that I curate the exam, and of course, I'm a speaker at the Euro on the CNCF. Three things that you can know about me is that I love to share knowledge, something that I'm doing right now. I also like to play soccer with my friends and travel the world with my favorite person, which is my wife. So those are the three things that you need to know about me. And today we got the agenda, which is going to be 4 topics that we're going to cover, including the demo. And first, we're going to talk about Ssl, TLS, why, what is it, what we needed, Acme, what that is, and Let's Encrypt, of course, which is part of the title, and Cert-manager. So those are the 3 main topics that we're going to cover as a concepts, and then we're going to do a demo so you guys can tie all that thing together in your hand. Okay. The first thing is, what is Ssl? So Ssl, pretty easy. I'm not going to read all that paragraph. You can go and look it up for yourself. But in a nutshell, Ssl is the standard secure, it's a secure socket layer that is how we encrypt and we establish a secure connection between 2 points. In this case, will be your browser, the server. That's how we communicate. It also could be between services. So that's it in a nutshell. So you can go and explore on your own a little more behind it. Talk today is not specifically about Ssl, but I want you to just get an idea of what that means. It's just a secure layer that we establish between 2 points. All right. So with that said, now what is TLS? Well, you just told me that Ssl Angel is for establishing secure connections, and then you tell me now about TLS. Well, TLS is just in few words, it's just an upgrade that was done to Ssl. Now it's a little more secure. It includes all the type of option for encryption, which includes ECC, RSA, and DSA encryption. So just to summarize it, don't get too bothered about what it really is and the nitty-gritty stuff about TLS, but just keep in mind that TLS is just an upgrade that was done to Ssl. So you can always say Ssl/TLS. It's not gonna hurt anyone, but in that way you can understand that they all kind of like work in the same bucket. It's just securing 2 points, a connection between 2 points. But of course, we need to make it more confusing. So what the heck is HTTPS? So HTTPS is the acronym is Hypertext Transfer Protocol Secure. So it's basically every website is HTTP. If you look at your browser, this one has just another S, which all it means is secure, right? And that's how your browser identifies, oh, this is a secure connection. It's at the browser level, right? So that's kind of what it is. So don't get too hung up on that one. However, you need to understand that you should be browsing always HTTPS websites. Was I mute?
Sorry, I had like some background noise. I have to mute everyone, and I muted you too. Sorry about that.
No, it's okay.
My bad.
What part was I mute? Here in the HTTPS or before that?
No, this like really happened like 5 seconds ago.
Oh, okay.
Sorry about that.
Yeah, I just wanted to make sure that I didn't have to go back the whole slides. But anyways, good. So that's what HTTPS is for. Now, so how Ssl and TLS works, and I know some of you out there will say, hey, well, but Ssl and TLS does not perform the same way. I know, but like I said before, I'm going to keep it simple. I'm always going to say SSL/TLS. So people that at least know SSL understand the relationship between the two. They're just an upgrade. But here is how TLS itself works. So just a quick recap of the graphics here. It's a start synchronization first at the TCP level, which is the bearer connection, the transfer control protocol that is established between them. And then it starts the TLS, which is start with the first request. It does the acknowledgement, all that. So I just want to kind of clear something up here that usually can misunderstood or misuse. It's like, well, when you're using secure connections, it makes the website slower and connections slower. Well, as you can see here, 110 milliseconds, right? So it's not really that slow for the internet that we have nowadays. There's a lot of ways that you can make it a little faster, but it's not going to be, no one's going to notice, believe me. There might be some specific system that might need to have a really low latency. That could be some cases where you might want to do some specific work on the TLS side. And I don't want to get too deep on that, but just keep in mind that it's not that bad. I mean, we won't notice it, or eyes won't notice it, right? The computer might, but not us. But it's not slow, right? And this is kind of the process that the system, the system does when they're doing a TLS connection. So it's always a TCP engagement first, and then happens the TLS on top of the TCP, right? So that's kind of how it works. So the kit version of TLS, SSL, all that is this simple. Just always teach your kids or anyone in your family to make sure that your browser is always with the green lock, and that's about it. So that's the kit version of secure connections, TLS, SSL. Just keep that in mind. That's the kit version, right? But of course, I had to give you the whole explanation and tell you all these technology before getting here, so you kind of see the reason why the kit version is the best one. So now let's get more into what is Let's Encrypt. So Let's Encrypt is a free and automated open source certificate authority, right? So what they do is they automatically provision certificate authority that you can use to then create your own secure certificates. This is actually based in multiple protocols. One of them is called Acme, which is the one that you can see on your right. And Acme is, you can see the link there, and once I share this presentation, you can go ahead and look more into that. It's a proposal for it's a standard proposal for how encryption happens, and this is where Let's Encrypt is basically basing his own system in. This is kind of how it works. So it's established multiple challenge per se. So just to give you a summarized version, what it does is, first, when you have your IP server, you just make a request. Before this is not about the website. You just make a request. It just verify that the IP belongs to that domain in an automatic fashion way, and then creates a certificate authority. And that's what they give you to provision your SSL that you will see, your green check mark. And I will show you that in the demo. It's going to be easier to understand. So just bear with me that that's how it works. So it does a verification first with your server, your IP, and make sure that you really own that. It does it with multiple type of challenges. One of them could be either HTTP1, which is just making sure that that specific URL, you own it and it's pointing to the right IP, or it can be done at the DNS level, which at that case, you can plug it in with GoDaddy, with Google DNS, with AWS Route 53, whatever you have that they support. You can just plug that in, and he will know that that domain belongs to you. Hence, he can just provision as many certificates as you want. And you can do wildcards and all that stuff. There is a lot of ways that this happens. The most common one is using a tool called Certbot, which is a tool that you can just use right now. You can download and provision your own certificates. There's other tools that can be used. There's Go libraries, there's ROS implementations, there's PHP implementations, you name it. So there's a lot of clients that you can use for that. So there's not only that one, but that's the one most widely used, is the one that everyone basically knows and is the most supported. But just keep in mind that you can use more tools to use Let's Encrypt other than Cert-bot. All right. So now, what is Cert-manager? So Cert-manager is a project in the CNCF. Right now, they are in the sandbox state, which basically means that they are in the process of becoming an official project of the Cloud Native Foundation. However, the beginnings, it was created by JetStack in order to create this way of using this Cert-bot. How can I implement this in Kubernetes? How can I make secure connections using Kubernetes? Because one of the things that happened with the Let's Encrypt that I didn't mention is that Let's Encrypt has a downside, which is the certificates only are valid for 90 days, meaning that every 90 days you need to go and renew your certificate. So this can be done, all right? So you can make a reminder on your calendar and say every 85, 89 days, I will just go and renew my certificate. However, that's not at all, efficient, because imagine that you now have to provision not one server, 2 servers, but it could be 100, 1,000 servers. So that's not efficient. So that's why they come up with this tool where they can be done automatically. So Cert-manager is going to grab your information, it's going to do all the challenges, and every 90 days or before the 90 days expiration, you just go grab the new certificate, renews it, and get it back into the system, and you don't have to do one thing for that. So that's really nice that they come up with this tool. It started as a Cube Lego, that was the first name, and then it became a Cert-manager, which is a little more complete tool. So of course, Cert-manager does not only work with Let's Encrypt, just to mention that, it also works with HashiCorp, Vault, Benafi, and all the ones. So you don't have to only use Let's Encrypt. We're going to use Let's Encrypt in this demo today because it's the easiest, and of course it's open source. We're going to be doing a lot of open source stuff here. But if you have your own certificate and you have it stored in HashiCorp, for example, that's fine. You can just use it. You can download your DigiCert or Commodore, whatever you're using right now, and put in your HashiVault, and that's fine. It works as well. And then you only have one source of truth that you can just keep renewing instead of having to worry about Let's Encrypt. So that's kind of like what Cert-manager is for and how it works. It works like this. As you can see, Cert-manager is in the center, and then we have the different type of, let's call it provisioners. So the provisioners are Let's Encrypt, that actually Let's Encrypt have 2 APIs, have the production API, which has some limits. You can only make some requests every now and then. And then you have the staging API, which is not going to give you a super secure certificate in the, you won't see the green lock, but it's going to give you like how it works. So you can test all your system before you go to production, which is nice. And then once you move to production, then they will provision the real certificate with everything that you need. But also, as you can see here, you can have Vault and Benafi. And then Cert-manager is the one that actually talks to your internal Kubernetes using CRDs. And these CRDs are certificates and issuers. I'm going to show you a couple of those examples in demo, but just to talk about it a little bit, issuers are the ones that connect Cert-manager with the actual provisioner of the certificate. It just manages that connection. And then the certificate is the one that talks to the issuer and say, okay, I need now a certificate for this, either a specific domain, or I need a certificate for this wildcard domain. So regardless of what you need, the certificate is the one handling that. And at the end, what the certificate does, it just keep in sync Kubernetes secrets. I don't know if you, in how it works inside Kubernetes when you want to, when you want to create certificates, there is a specific secret in Kubernetes that I'm going to show you how it looks like, that they are specific for certificates. So in this case, what the Cert-manager would do is just keep them in sync. So when a new certificate comes in, it's just going to replace the old certificate in the secret, remove that, and put the new one, and you will have to do it. So that's kind of like how Cert-manager works in kind of summarized way. Of course, it's a little more complex system, but this is like the summarized version of how it works. So I don't know, you guys can stop me at any time if there's a question either in the YouTube channel or here in the chat. So feel free to stop me if I'm going too fast. I want to make sure that you all have all information and questions answered during this time. Okay. So I think we got to the demo time. The presentation was quite fast. So let's kind of like describe what we're gonna be doing on this demo, and then we're just gonna jump into the demo right away. So the first thing that we're gonna do is install the Cert-manager. Then we're gonna deploy an application without Is Ssl, so you guys can see how it looks like. Right after, we're gonna create an issuer, and there's two types of issuers: the namespace level issuer and the cluster level issuer. I'm going to explain what those tools are for and when you can use them, and what are scenarios. And of course, they're both going to be type of Acme issuers. And of course, at the end, we need to enable Is Ssl so we can deploy an application and see actually the green logo. All right. So any questions so far? We good? All right. All right, so let me then change my sharing screen to the...
And there's no questions on YouTube too, so go ahead, Angel.
All right, thank you. So let me know where you can see my screen. And let me know, please, if this is a good size. I'm sometimes just don't know if it's good. Is it good?
Let me see. The YouTube hasn't caught up on this.
Yeah, I just want to make sure that, yeah, I just want to make sure that,
well, but
okay, I just want to make sure that the size is good, because sometimes it's just hard to read. So I want to, if I have to make it bigger, I'll make it bigger. It's fine. All right. So, all right. This is just a repo which I'm gonna upload later to the foundation. Sorry, to the meetup repository, and I'll share later. Yes. Yeah, I see Sat here is asking, is this a GitHub repo? Yes. I will update the meetup later with the link to this repo for sure. Yes, I'm gonna share it.
Thank you.
So here we got some of the requirements that I want to just share with you guys before we get started. Of course, there's some stuff that I did already just to make sure that we don't waste too much time in things that are not related to the specific of the talk. So first we did I'm using DigitalOcean, and full disclaimer, they're not a sponsor of this channel or anything like that. It's just full simplicity. Just keep that in mind. So I don't want people to think that I will promoting DigitalOcean or anything like that. So once I did that, all I did is just created, I log in into DigitalOcean using the CLI, which I'm sharing all the commands that I'm using, so you guys can follow along if you have an account there. I created a cluster, which I didn't specify any type of property. It's just the simplest plain cluster you can find there. So that's why you can see here the code that I run. And just to verify that, let's just run a quick check and just see Kubernetes, QCTL, current context. And right now we got, yep, the DO and YC1 South Florida. So we're good. That means that we are in the right cluster and we are in the right context. So we are in the good place. Another prerequisite that I did prior to the meetup is I installed Nginx Ingress controller. Same thing. It doesn't have to be Nginx Ingress controller. Could be any other Ingress controller that you want. It's not really the point of the talk, but I just installed this one for simplicity. Just one thing that keep in mind with any Ingress controller that you install in DigitalOcean, it was something that actually took me some time to find out because they don't quite put that on documentation, that you need to have some sort of like specific annotations on the service in order to work. I think Nginx does have that in the kubectl apply file when you do that one. However, if you use Helm, there's some annotation that you need to set. So you might need to do something like controller and then service and then annotations, if I'm not mistaken, and then you need to add, I think is, what is it? I have it right. I have it somewhere here. So I'll find it, but it's kind of like a weird annotation. I think I can find it over here. I'm going to show you real quick because this is interesting and important. Otherwise, you guys will not be able to follow along. kubectl, and then in the Nginx English controller in SVC. All right, anytime. There you go. Okay, so if I describe the SVC that we have, you will notice that there is a specific annotation here. There you go, this one. Service Veda Kubernetes IO, DO balancer, blah, 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 protocol true. So this annotation, you need to add it here. Otherwise, it won't work. So keep just that in mind. I think this is the way that you can do it on Helm, but I can confirm that for you guys later and upload it. But definitely you need this, and I think you also need the host name. We'll find out if it doesn't work because I do have an example that it needed the host name. So we'll find out. But this is definitely something that you need. All right, so that's about it on this side. Those are the prerequisites that I ran prior to this. So let's go ahead and start literally with the Cert-manager. So the first thing that we need with Cert-manager is just create the namespace, add the repo, and then we're going to install it with Helm. So let's do that real quick. Just create the repo real quick. This part I'm going to do a little quick because I want to make sure that we spend more time on the actual file. So let me just do this. I'm just adding the repo. I'm just updating the repo so I get the latest information. And here is the actual installer. So, all right. So just to talk about this line just for a second. So all I'm doing here is I'm saying Helm install the Cert-manager. I'm going to call it this way. It is the repo. I want in this specific namespace, and I want this version. Please make sure with Cert-manager that you specify a version always. Something that I had in the past is that I didn't specify the version of Cert-manager, and I just installed X version, and they do make some heavy change sometime. So just keep that in mind that you do that. Sorry, I have my third throat. So just keep in mind that you always specify the version. That's a good practice anyways, but especially with them. And we're just gonna set a flag called install CRDs true. So there's multiple ways that you can install Cert-manager. You will see on the website. This is the one that I found the easiest. And this one includes also the CRD. So all these certificate CRDs, all these issuers, it just can install right away alongside with the core. So let's install that. And while that is installing, let me just take a look at what is next. And here is how we're going to verify that the installation is good. All right, so let's just give it a second. And this is actually a good time to ask questions if you have one. I think I need to move my face because it's kind of, there you go. Let me just move it over here because it's kind of getting in the middle. All right, so Helm says that everything is good. And we're going to check that out. So, okay, sorry. So we got here all the pods that are running on the Cert-manager. Just a quick thing. this is just a Cert-manager actual system, the one that is gonna do all the work. There's a couple more. Let's just not worry about those right now. There's a little more. I'll say we will need more time to actually dig in every single one of those. Just keep in mind that these are the 3 main pods that are running inside the Cert-manager. We're mostly going to be working on this one for today. The other ones, we can just have another talk about them and what they do and how we can work with them. So that says that everything is running. So that means that we're good to go. Now, where's the first thing that we're going to be doing is, well, let's check it out. The first step that we said we're going to deploy an application. So we're going to deploy an application. I have one called Eco, and I'm going to show real quick what it does. So it's a deployment. Let me just hide this so we don't have a big. All right, so it's a deployment. Pretty simple. It doesn't do much. All it does is just shows on the website, hello world. That's all it does. And we're going to just deploy and see what we can get. Of course, we cannot deploy this without deploying a service, which is simple as well. It's just going to listen in 80, and we're going to deploy an ingress. But if you notice, I have an ingress that won't have Is Ssl set up. And then we're going to set up another one which does have Is Ssl, okay? For now, let's just keep it simple. All right, so what I'm going to do, I'm just going to first kubectl apply, and I'm going to drop it right on the default namespace. So it's not much here to do. Let's do, the file is going to be, oh, I need to get into the folder angel. So let's get inside the folder, inside the chapter 6. And there you go, we go. Okay, so let's do kubectl apply. And now let's apply the eco, and we're gonna press deployment. Let's do it. We got the deployment in. Now let's do the service. We got the service in. It just confirmed that we got both. So we are good to go. So we got the pod is running. We got the service is there. It doesn't have an external IP because we're gonna be using controllers and English controllers. Now let's do kubectl apply, and then echo. Let's do the English controller, but the one without the SSL. Let's do that. So we got the ingress. It might take a couple minutes to actually deploy, but let's just give it a second. So first, let's do this. All right, and let me just double check what's the, okay, so it's supposed to reply to echo, la hora que also is.io. So let's try that out. So first, let's do a crawl and see if we got it. Hello world, there you go. So that means that we actually have a hello world scenario. So you guys don't feel that I'm lying to you. Let's do in the browser. So we got in the browser, hello world. There you go. Now, just put attention to, like, it's not secure. Of course, we haven't done any HTTPS, no TLS, no SSL, nothing in here. So just plain website. I want to show you real quick what I did on DigitalOcean. So all I did is just put this DNS here, and all I did is just copy the IP from the English controller and basically point everything that is dev here to that after, I mean, wildcard dev all the way here. So please try to not do a DDoS attack right now, so we can actually finish this talk. I know some of you might have some ideas, but don't do it. So that's pretty much it. So, and if you want to know how I got the IP for the English controller, all you have to do is just get the English controller Nginx and then do get and then the service, and that should give you the load balancer IP right here. That's it. Okay. Good to go. So we got the one step down, which is deploying an application with no SSL. Step two. Step two is going to be a little more like a reading, less actually practicing, because it doesn't, I don't want to spend too much time on this one. It's more to show you multiple ways that you can actually deploy a certificate. So here, this is an example of how we're going to create a self-signed certificate. So what is a self-signed certificate? A self-signed certificate is like you create your own certificate authority, just like whatever you want to call it. I don't know, angel certificate company, and it's self-signed. Of course, it's not going to be secure. No one will care about that certificate because you're not an entity that is, you know, approved or recognized by the browsers. However, you can use a self-signed certificate internally. Like if you are heavy into gRPC and that kind of communications, those are the ones that you basically create, because you don't care about having a official certificate from a specific company. You can use just a self-signed certificate, just keep it secure so no one knows it. And that's how you communicate secure between two layers. So just because it's self-signed doesn't mean that it's not secure. It just means that the browser wouldn't know who they are. But internally, TCP connections, they just fine. They don't care. All they care about is like, do I know you? Yes. Can we just acknowledge and start the connection? Yes, you're good to go. That's kind of like the self-signed certificate talk. Because sometimes people think like, oh, if it's not secure. It is secure. It's just not specifically the way that a browser will understand it. So it's pretty simple. I'm just creating an namespace. I'm creating an issuer, and this is a way to introduce an issuer. An issuer is just an object that is going to hold the information of why am I going to issue? What is the type of certificate that I'm going to give you? In this case, it's self-signed. There's not much else to do here. Of course, in this object, if you go to the website, you can create, I think you can specify things like the company name or something like that, I believe. But we're not gonna do that right here because we don't care too much about this one. It's just an example. So if you do an empty object, what it's gonna do is just gonna create it whatever random information. Then we're gonna create the certificate. So the certificate is gonna use the issuer to then create keep in sync the secrets. Before I run this, I want to show you something so you guys see what it looks like. So I'm going to show you all the namespace that I have. So I have no namespace called Cert-manager -test. So there's nothing here. The first thing that we're going to be doing then is going to create execute that file. So apply -f as a file, and we're going to create a self-signed certificate. So it's going to give me a namespace, it's going to give me an issuer and a certificate. Now, what that means is that now I have a way for me to say, so I want to see all the issuers in the namespace Cert-manager test. And you will see that there's one called self-sign, and the status ready is true. And let's see what that means. So instead of doing the get, let's do now a describe. With the describe, we can see more information about the certificate. In this case, while it's giving us all the object, the entire object, it's also going to give us more stuff like, okay, it is ready, it is true, the type, all this stuff, that all the events that are happening. In this case, it basically did nothing because it's a self-sign, so everything happens inside the cluster. So there's not much to do here. But you will compare when we show the other one, there is going to be more events. So that's a certificate. If we want to see now, all right, so I want to see in the same namespace because we are in the same namespace. If we want to see now all the certificates, let's just say describe certificates. And now let's see, we got one called self-signed certificate. And here you will see more information. So in the issuer, there was not much to see because it's basically self-signed. So there's not much to do. However, here is a certificate. You will see that is more information. It's saying, okay, cool, for this self-signed dev, la hora K8 SIO, we're gonna have some of these conditions. So the certificate is ready and it has no expiration at all. But if you see in the events, it started with first the certificate successfully issued, then it created a new request, stored the private key, which I'm going to show you what that means, and then is issuing the certificate as a secret. And it's telling you does not exist. This is actually very cool because it basically first is checking, do I have already a secret assigned to this certificate? If I don't, I'm going to create it. But if I do, I'm going to just renew it. So this is actually very important because this is how he keeps track of like, what do I have and what do I have to renew? So this is pretty cool. And last but not least, I'm going to show you in the same namespace. Now, what is a secret? The secrets, if I can type. And now you see that we have two secrets. And this one was created 2 minutes ago, literally. And in this secret, we're going to see, let's try secrets. And let's describe this one. Now we're going to see that we have a CA, right, which is the certificate of authority. And this is the difference between self-sign and other certificates. We have the CA right there. We got the TLS and we got the key. So for self-signs, usually you have the CA literally right there because you need to have all the bundle. And this is how it gets created. Now, pay attention to the type. When I was saying about the secrets on Kubernetes, Kubernetes have multiple type of secrets. You have the type of generic secret, which is just whatever information you want to just store secure. And that's another topic that I want to talk about that is not really secure, but we'll talk about later. Then you have the TLS and you have the registry. So the registry is the one that you use for storing information about how to talk to multiple registry. It could be Docker, could be GCR, could be AWS ECR, whatever you have. And then you have TLS, which is to store this type of information, the ones that we're showing here. So just keep that in mind. All right. So that's it with the self-signed. So not much here. Like I say, it's just reading and show you how it works. Now let's get a little more into the one that we really want to talk about today, which is the ones that we can use in the browser. Now, for that, we have the Acme cluster issuer. So I'm going to show you this real quick, and then we'll explore the other ones. So the cluster issuer. So if you notice in the self-sign that we have here, I created a issuer, and then I specify a namespace. So in this one, I'm just saying cluster issuer, and I'm not specifying a namespace. What's the difference? None. The only difference really between them is not about how they work, is their scope. So in the issuer, you only can issue certificates inside that namespace and only work in that namespace. This one, it just doesn't care about namespacing. They just work with any type of issuer, any type of certificate, any type of namespace. When this is helpful, well, in multiple ways. If you have multi-tenants and every tenant, for example, have a namespace, you don't want them to be able to see someone else's certificates for sure. So that's why maybe having an issuer makes sense in those scenarios. When the cluster issuer makes sense, well, you are the only tenant and all your services are inside the cluster. So you might not need to make it specific to an namespace. However, I will argue, my personal opinion, that you should always try to use issuer and not cluster issuers, because issuers, first, it's already contained in one place, in only one namespace. So by default, it's a little more secure. So there won't be a case where one information will go across namespaces. And the other side of the coin, because when you have anything that is cluster-wide permissions in Kubernetes, you should be careful, because having those type of permissions basically telling Kubernetes, hey, this service, in this case, Cert-manager, when I create a cluster issuer, have access, wide access to my cluster, even if it's just to watch namespaces or secrets. So unless you can verify and make sure that they don't have all access that they don't really need, I will avoid at all costs using cluster or anything that is cluster wide. However, we're going to use it here. Why not? It's just an example, but just keep that in mind. That's a security tip. So, well, we just naming it. Doesn't really matter what the name is. Here, I'm giving you this example of how we use Acme. So we're saying we're going to use the protocol Acme, and the server is Let's Encrypt. This is how we tie things together. So we're using protocol on Acme. Let's Encrypt is the one that is going to provide that service to me. I'm going to use the production API because I want to see the green lock here in this case. I'm specifying the preferred chain. So this one, they changed it recently. You don't have to specify. You can just leave it alone, and it will give you the latest and greatest, the one they have. I like to be more specific, and especially when I'm writing my YAMLs on Kubernetes, I want to make sure that there is no surprises. So here I'm just specifying I want to use this specific preferred chain. You need to give it an email. That email is the one that he will use to tie to your account. So it will create an account. If that email is not there, it will create an account, tie those certificates to this account. And then once that's done, for example, I delete the cluster and I create another one later. Even if I use the same email, he will understand, oh, I know this email. I can just give you the certificate. So that's kind of like something that to keep that in mind. Then we have the private key where I want to store this information. So it's not about the certificate information, it's about the information that Let's Encrypt is going to give me to give it as a configuration. So there is going to be all the information related to like renewables, expiration time, all the stuff is going to be stored there in my account. So that's the private secret that you can see here. Now, the resolvers is when we actually going to be working with the certificates. So in this case, we're going to be using HTTP 01, and we're going to be using Ingress. And in this case, like I say, I like to specify I want to use the Nginx one. Why? Because you could have multiple HTTP1 resolvers. You can have as many as you want. And let's say that you have another one that is resolving and using Azure proxy, and then because you're running Azure proxy and Nginx both in the same cluster, that's completely possible. So there's nothing stopping you to doing that. I don't see a real benefit yet, but you can do it. So you can have multiple Ingress control running. But this is how you specify how it's going to resolve those challenges and how it's going to say, okay, now this is good. A couple of things here. I'm using a selector and say, hey, look for anything that is using this label. So any Ingress in my system, in this case, is a cluster issuer. If it's an issuer, I will look into everything inside the namespace. Just keep that in mind. But in this case, I'm saying, if you find in the whole cluster an ingress that has this label equals true, then you basically use that as a link. Now you're going to watch for that ingress. So it's establishing a link via labels. This is pretty nice. Actually, in prior versions, there was a different way to do this. You had to do like some crazy stuff in order to make it work. This is actually one of the best features that I think they come out with lately, which is tying those via labels, because now all you need to make sure that you label things in the way that you want it, and that's it. You don't have to worry about how many do I have or if I have to do anything manually. So this is pretty cool. And this is it. This is just the issuer. Okay. So without further ado, I'm just gonna deploy the issuer and see how it looks like, and then I'm gonna show you how the process works. So let's do a kubectl minus n. I'm just gonna apply minus f, and then let's do the Acme close issuer. All right, crossing fingers. There you go. Cool. So now I'm gonna show you something really nice. I'm gonna go to a Cert-manager, and I'm gonna say, show me the logs of your pod, and let's just watch the logs for a second. I know it might sound like, oh, this is a lot, but actually you see here, it say it found a cluster issuer. So you already say, oh, there is a cluster issuer that just got created, right? So now it's gonna say, well, once it goes through a process, let's just watch here for a second. Now it's going to start doing a challenge. Actually, I think it already did. It kind of says here, this is the name of the issuer, is verifying. Because what it's going to be doing now is going to say, all right, can I talk to Let's Encrypt in the server and say, I do have this domain, whatever, that I need to verify. I need to know if this guy really owns it. So Let's Encrypt is going to send an Acme challenge to that domain. That domain is backed up for an IP, which is my DigitalOcean. And then based on that, this guy is going to receive that information and say, well, let me just see if this tied up together. And then it's going to do the whole cycle. So once he verifies that this challenge that started here from this point did the round to Let's Encrypt back to the server in the other way, he can tie these two together and say, yes, this actually belongs to this IP, right? So this is a very, 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 summarized version of how it works. But just to give an idea, it's just doing a quick big round and making sure that this IP and these domains are together and belong together, that I'm not trying to prove anything here. So we just need to give it a second and see if it's done or not, or if we had an error. So what I'm going to do now, I'm just going to leave it here, and I'm going to open another tab. There you go. Let me log in again. And now let's take a look at the cluster issuers. So I'm going to describe cluster issuers and see if we got something different. All right. Okay. So as you can see here, it just said the same information that we got prior to that. But look at this. The conditions right now, it says the admin account was registered, right? So this, we're good. Actually, that's why it was that fast, because this was already registered. So it didn't have to do the whole saving information for my account, because it already recognized my email. So that's why it was that easy, right? So first step, that was good, which is why that now explains why it didn't do a lot. It just made a couple of requests and that's it. Now, when are we going to see a lot? Is when we create the certificate. So let's do that now. I think it's this one. There you go. So now we're going to go and install the Is Ssl. And now let me explain this real quick before I get into this. So I'm going to put this on the side because I don't want to lose sight of this real quick. So if you look at here, now I'm going to deploy the version of the app that is SSL. So, and for that, let's do something better. So instead of having the exact same domain, let me just, 1 second. Okay, this is echo here, blah, blah, blah. And then let's do echo SSL. And then let's do echo SSL. So why am I doing this? Because I want to keep both. I want to keep the non-SSL version and I want to keep the SSL version so I can show you and compare. So in this case, I'm going to create another ingress, right? So pretty simple, straightforward, nothing fancy. And same thing is the class Nginx. This is just the ingress controller. I'm telling them, hey, by the way, when you find this annotation is pretty cool. I like it. So when you make this a challenge and you actually find a link, edit this ingress controller in place. So just edit it, right? So it doesn't create more stuff, more headaches. And I'm just adding another annotation for the Cert-manager issuer that I'm specifying what issuer do I want to use. I don't have to do this because I already using labels here, as you can see. But I mean, this is kind of maybe an OCD from me, but I do like to be specific. So I'm specifying what cluster I want to use, and I'm specifying the way that they can connect. I could do either or. Just keep that in mind, because I mean, maybe you want to just get rid of this and that's fine. So, or you can get rid of the labels if you don't like the labels. So either or, I just use both. Doesn't really matter for me. And then here's the magic. So I'm saying this ingress is going to be the type TLS. This is the host that I want to have for the TLS version, and this is a secret. So this is important because this secret right here is the one that the certificate that is going to be created on the fly is going to basically use that secret name to create the secret that we're going to use to store the information. And to prove that to you, I'm going to go back here, and once again, if I do kubectl, and I think this is in the default space, get secrets, right? So there's no secret called echo def whatever. So there's none, right? So we'll create it on the fly. So let's do that. Let's apply -f, and then let's do the echo, and then let's do the SSL. All right, so it got created, it got configured. Did I save this? Yeah, I did save it. Yeah. Oh, I see what happened. All right, so I messed up. I changed everything but the name. Yeah. So I'm gonna do this. Well, let's leave it like that. It doesn't matter right now. We can always look into that later. So here's what I want to show you. Okay, so if I can do this, I can do it. Okay. What's going on? Why is not? Okay, that was interesting. All right, so now let me show you that now you see more information since our blank lines. So all this doing here, and I know that it's hard to read, so don't worry, but you can spot here is doing self-check, making sure that it's doing the challenge. All that is just being done right now. So it's just making sure that I do really own that IP, and that IP can talk to that ingress and all that. So there's some check fail, it looks like. I'm gonna check it out why it's failing. And I believe if it doesn't work, it's because the annotation that I was missing about the host name. So I'm pretty sure about it. So we'll get that resolved, no worries. So, but before that, I'm gonna show you how it looks like on the actual certificate side. So now we can see that we have in this namespace a new certificate that we didn't have before. And it's called echo. And if we do describe it, it's saying it created a temporary certificate, it created a new certificate request, store the new key and the temporary secret and the resource. So what this is saying is that, okay, so I found a new certificate that I need to provision, okay? But while I'm doing that, I'm gonna create a request and create like a fake one, some sort of like a temporary secret. So I can keep using it. I can right now go to my browser and try to get with the, well, it's giving me not found. Because I changed the URL. So let's do SSL. So you see, it's actually saying now something different. It's not telling me, hey, this, I don't know who they are. It's just telling you, okay, are you using a temporary certificate, something that I don't trust as a browser. So this is good. It's basically doing what it's supposed to be doing. It's provisioning something. You said random number, while it's trying to do the actual, validation, which we're gonna fix right now. No worries. So that's what it's doing. Now, the reason why I think it's failing, and I think is because I can just go back in time. Let me go back. Sorry, 1 second, because I don't remember exactly. I think it's this one. No, it's this one, and no, not that one. Is, oh, I know. I just put it here. Here. No, it's not happening. Give me 1 second, guys. Sorry about that. I know I can do it. Where is it? I had it over here. Okay. It is easy if you just leave the lotion. Host name annotation. And I believe this is the issue because of the issue with the load balancers that they have. And is the host name the one that we need? Let me just search for it so we can host name annotation. Come on, there you go, found it. All right, so this is the annotation that I was missing, which I believe is the issue why it's not working. All right, so, and then we're gonna open this. We're gonna do some live editing. Don't do this at home. Okay, and then let's do kubectl minus n English control nginx. Let's do it. There you go. And now let's go edit. And we're gonna, oh, no, that was too much. We're gonna edit the service English controller. That's the one that we need to edit. And then here, we're gonna go to annotations right here. And then we're gonna paste that in there. And then we're gonna put the actual host name, which is dev.hora. We're gonna save that. It's gonna edit it. And hopefully that will solve the issue. So let's just look at the logs again. If not, what we need to do is just need to kind of like delete the certificate and create it again. So let's check out the logs and see if that helps. All right, so deleting the pod, doing that, blah, 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 certificate request echo, found status, last transaction, queuing item. Okay, I think it did. Let's just try. Boom, there you go. That was the issue. So now this is the success. Now we got, of course, I'm using Brave, so Brave does not put this on green itself, but this is kind of like the same approach. Now we have a green check mark here. It says that is ISRG root x1 is given to this URL. It is trustable. You see, its certificate is valid. The details, everything that we have here is let's encrypt all the stuff, that information that no one reads, but believe me, it's important. And that's it. So we literally got a secure SSL website using Let's Encrypt with the protocol Acme and Cert-manager. Now, the good thing about this is that I don't have to worry about renewals because Cert-manager would do that for me. And I think that's it. I mean, questions, comments? You guys decide. I think we're on time, right? Yeah, we actually right on time.
Yes,
So
there's
that
no
was-
questions on YouTube. too.
Okay, shut it. What's up?
Oh, I said no questions.
Oh, I thought you said there was 2 questions. Okay, my bad. Okay. Any question here in the chat? Anything? Any comments? Or shall we just wrap up? I think that's it. So All right, so yeah, that was it. I appreciate one more time you guys the time. Hopefully, I provide you with value, and I'll keep doing this. Like I said, we took like a couple month out because of the holidays and that kind of stuff, and I was traveling, so I couldn't really uh, do this. But we're gonna get back on track. The plan for this year is to do it a couple of times a month instead of once a month. So just stay alert that we want to do a couple of times a month. Like always, we're looking for speakers. If you have anything that you want to share about Kubernetes and Cloud Native, feel free. You don't have to be an expert. Anything that you learn, it will help someone that might not know. So remember that this is a community, and we want to help everyone that we can. So let me know if you're interested on presenting anything that you can, definitely, I would love to schedule for you to talk. Oh, thank you, Paul. Thank you for joining. So, all right, everyone. Thank you so much. Looking forward to the next talk then, and we'll have some surprises here because we want to do a lot of cool stuff. So, all right. So happy Tuesday, and enjoy the rest of your night. Bye bye.